Good morning, good afternoon, or good evening, depending upon where you live around the world. Immediately upon finishing the last video that I saw was getting to be a little bit longer than what I want, I said that the next video will be touching on this hub design. It's likely not the type of hub I will be going with, but when you go through all these different iterations, you go from the left, you step through them, and you start to make observations and some conclusions upon what you'd learnt previously. In this case, I thought, well, if we section a tube into small segments and then weld our sides to them, that would both be relatively straightforward and achieve an elegant, efficient, structurally robust hub. In the that came from getting the central hub, this green hub, to a specific diameter as supplied by my local steel merchant. I thought, right, well, if I take this section of a tube, which is from point to point 40 millimeters, so if I just drew a line across there to there, showing down in the bottom right hand corner 40 millimeters, plus a 3 to 5 millimeter, or maybe a 3 millimeter plate, it would then lend itself to a strong saddle that can be bolted through the central tube. Because our struts are only at this distance out 3 or 4 millimeters different, we could scribe or mark our tube to those different heights, use a single model of this saddle, and making numerous, like the 6 of them for this hub, we could position them exactly right, and their struts would actually align. And I'm thinking, holy moly, this is actually sounding like not a bad idea, even though I probably won't use it. One of the things that I thought about, if I just zoom in just for a moment, these lines, by the way, are just for my alignment purposes. If I drew the hub out, maybe, whoops, not that, but this, sorry, moved it out 0.5 of a millimeter, again, the accuracy of SketchUp to use those typed in measurements is good, but it won't register it as far as a dimension. Oh, that was the previous video. But what happens is that the points of the segment, because you're using the segment, which is part of this tube, same size, on the outside, of course the radius is slightly smaller than the outside radius of the green hub, meaning that these points here and here are the ones touching, and in theory they should locate along the vertical axis of this tube almost automatically. That the orientation should nest into that shape. And of course, if we've got a bolt in here or a welded in stud, when we tighten it up from the inside, it's effectively going to attempt to crush the two surfaces together, making incredible grip pressure along these two quite sharp edges, making the self-alignment and pressure of the clamping of the bolt structurally very good. And having a pivot allows any discrepancies to be compensated for. So that allows the fudge factor of getting it wrong to be built in to these hubs. And it's not that these hubs are particularly clever, they're not, but that you could make loads of the things easily is what's, I think, quite good. You don't have to have a hub with the wings firmly attached or welded in specific positions that are dead accurate. This allows for a little bit of inherent fudge factor going on when you're assembling. You could cut these, or have them cut to a specific width, 40 millimeters for instance. Have these plates 3 millimeters up to 5 millimeter. It makes it very rigid, and have someone assemble them, because these plates will sit straight on the welder's bench flat. The sides to them, the wings on either side, would be able to press up against them and be held in place rigidly at 90 degrees to the welding bench with welding magnets. They can be MIG'd or TIG'd or arc welded together, and you wind up in quick order with a saddle that can be used for all domes. Not just the 6-pointed hub here, but the 5 and the 2 and etc. You can use these as a universal junction point for a strut and a central hub. Starts to be appealing. That they can be fabricated quickly and easily makes them cheaper. You may be able to, if you're a welder, do them yourself. Me, I'm not a welder. As I tell people, I don't weld, I glue. So, I mean, with the MIG welder, I still glue. You don't want me to do anything important. But this shape can be created with a template, routed. It probably won't wind up in the shape, but routed into this shape, and relative to the height of these saddles, they can be moved up and down to suit your strut position. I like it more and more. But I come back to, I still want to be able to make a hub strut attachment that can be done in a workshop of the Joe Average or Joanne Average that wants to build a dome. Because if you want to make alternate versions of it, you don't really want to be tied to having to have these laser cut and welded by specialist engineers or companies. Whereas what I'm contemplating doing is that you, me, and most other enthusiasts will be able to build the dome well using hand tools, basically, and a few maybe a compound miter saw, maybe. Okay, well, that was it. That was the quick one. It's getting a little bit late now. I don't know whether I will have another video in me tonight, and besides which, you won't be watching these when I make them. It could be days or weeks before they get loaded, so you won't know. I'm blathering on, so I'm going to end it here, and I'll come back in the next video with some insightful information, no doubt. Or not. Okay, see you later. Bye.